Back with me in the studio today is Altech Chemicals Managing Director, Iggy Tan. How are you, Iggy? Good to have you back.
Thanks for having me.
So, Iggy, you've recently announced some exciting news surrounding your sodium alumina solid-state batteries. What more can you tell us about this announcement?
Yeah, our solid-state batteries are actually fire and explosion proof. So unlike lithium-ion batteries, they've been in the news recently for having fires and thermal runaways. Our new technology batteries are actually fire and explosion proof. And also, the life of the battery is actually beyond 15 years. So lithium-ion batteries generally last about 8 to 10 years. Our batteries will last beyond 15 years. And finally, most lithium-ion batteries operate in a narrow temperature range. And this is a problem in very cold climates or desert climates. Our batteries will operate in a much wider temperature range and will operate in the cold as well as in the desert climate. So we've just announced a joint venture to commercialize these sodium alumina solid-state batteries for a 100-megawatt plant in Saxony, Germany.
You did mention there that some of the critical metals that are being used in lithium-ion batteries today are causing some concerns for the industry. Can you detail a little bit more about what sets you apart?
Yes, as you know, in lithium-ion batteries, obviously lithium is the major component in these batteries. And you would have seen that the price of lithium has increased nearly sixfold in the last 12 months. So that's putting a lot of pressure on the production costs of lithium batteries. The other major component of lithium batteries is actually graphite and copper, which is on the anode part of the battery. Now, graphite is 90% of graphite on the anode side is produced from China, and it represents some geopolitical risk for the battery industry. Copper itself, they believe there will be a crunch of supply for copper. In general, an electric vehicle uses 2.5 times more copper than a standard vehicle. And there's a recent study that shows that there won't be enough copper to meet all the EVs forecast to come. And that essentially will be a copper crunch. And finally, cobalt is the other main component in some of the lithium-ion batteries. And 70% of the world cobalt supply comes from the Congo in Africa. With the recent human rights abuses, it becomes an ethical concern for cobalt supply around the world. The beauty of our batteries is essentially we use table salt or the sodium ions in the battery. And sodium is actually very reactive, very similar to lithium, and it performs really well in the battery. We don't have any anode part of the battery. We don't have graphite. We don't have copper, and we don't have cobalt. So if you think about it, those critical elements in a normal lithium battery, in our batteries, we don't have to worry about. So there's no pressure on rising prices or supply chain concerns.
So really within that context, you're primed to enter commercialization for these kind of batteries.
Yes, we partner up with a leading German institute called Fraunhofer IKTS. They're a battery institute, and they have been working on this technology for the last 8 years. They've nearly spent 35 million euros in research and development. They operate a 25 million euro pilot plant in Germany today. They're already producing these batteries, and these batteries are really in a performance testing program and essentially ready to commercialize. IKTS have been looking for a partner that has land in Germany, has a background in battery technology, and also some alumina technology, because the key part of the battery is a ceramic tube, which is the solid state part of that battery. So the major difference in this technology is that instead of the liquid electrolyte that is in a lithium battery, this is a solid state technology, which is where the industry is heading to.
You mentioned that key partnership with Fraunhofer. I'm wondering if you can detail for us how that came to be.
Yes, as I mentioned, we have been working with Fraunhofer IKTS on various projects, and through the process, they've selected us as the partner. We are the majority partner at 75% of the joint venture, and we are looking at building a 100 megawatt or 10,000 modules of these 10 kilowatt batteries in the state of Saxony, Germany. So we've commenced the feasibility study process, and we're looking to commercialize this. Now, as I said, a lot of the work has already been done. The product is already out there and it's ready to commercialize. So we've got a lot of certainty of getting this up and running.
Speaking of, really, the million-dollar question becomes, what is your path to commercialization for these batteries?
Yes, as I mentioned, we are working with IKTS, and we're looking for a German engineering company. And in the next phase, we will finalize the feasibility study for this project, and then we will proceed to funding of the project. Now, these batteries that we intend to produce are specifically for the grid storage market. We're not looking for e-mobility. They are ideal for actually grid storage. And in grid storage, essentially what you're doing is you are charging the batteries when the sun is shining and then using that energy during the nighttime. So that's one use of grid storage. And the other thing is also peak shaving.
So finally, Iggy, I'm just wondering if you can give shareholders a bit of insight into what's happening for the rest of the year for Altech.
Well, with this announcement, there are obviously lots of excitement, because really it's a game-changing technology for the grid storage market, and shareholders can look forward to lots of news around the development of this project. Very exciting project, and we're very excited to be working with IKTS in Germany to develop this 100 megawatt plant.
Well, we look forward to further updates from you and the team. Altech Chemicals Managing Director Yi Tan, thank you for your time.
Thank you for having me.